If you're advertising your entire VPC CIDR to your on-premises network through Cloud Router, you're probably exposing routes you never intended to share, and that's a security risk waiting to happen.
Okay, that sounds serious. What do you mean by advertising routes we didn't intend?
Hey everyone, welcome back to the Network Ninja CloudCast. I'm your host, and today we're diving deep into GCP Cloud Router custom route advertisements with my co-host Alex.
Hey everyone, I've been working with hybrid cloud setups lately, and honestly, BGP route management has been confusing me. Excited to finally understand this.
Perfect timing then, because today we're going to demystify how to control exactly which routes flow between GCP and your on-premises data center.
So let me start with the basic problem. When I set up a cloud VPN or dedicated interconnect to connect my on-prem network to GCP, what actually gets shared between them?
Great question. By default, Cloud Router uses what Google calls Advertise All Subnets mode. This means every subnet in your VPC automatically gets advertised to your on-premises routers via BGP. So if your VPC has subnets like 10.0.1.0 out of 24 for production, 10.0.2.0 out of 24 for development, and 10.0.3.0 out of 24 for a sensitive database tier, all three get announced to your on-prem network.
Wait, so my on-prem network would have routes to reach all of those, even if I only want them accessing production?
Exactly. And here's where it gets worse. Your on-prem routers now know how to reach that database subnet. Even if you have firewall rules blocking traffic, you've still leaked routing information about your network topology. Security teams hate this.
That makes sense. So how do we fix it?
This is where custom route advertisement comes in. Think of it like a postal service analogy. By default, Cloud Router is like a post office that publishes your complete home address, apartment number, and which room you're in. Custom route advertisement lets you say, only tell people my building address, nothing more specific.
So instead of advertising every subnet, I choose exactly what to share?
Precisely. In the GCP console, you navigate to Hybrid Connectivity, then Cloud Routers, select your router, and switch from Advertise All Subnets visible to Cloud Router to create custom routes. Then you explicitly add only the prefixes you want advertised. You could advertise just 10.0.1.0 out of 24 for production and nothing else.
Can I also advertise a summary route instead of individual subnets?
Yes, and this is a best practice. If your production subnets are 10.0.1.0 out of 24, 10.0.2.0 out of 24, and 10.0.3.0 out of 24, instead of advertising three routes, you could advertise 10.0.0.0 out of 22 as a summary. This reduces the number of routes your on-prem routers need to maintain and simplifies your routing table. Just make sure that summary actually covers only what you intend.
What about the other direction? Can I control what routes my on-prem network advertises to GCP?
Now you're thinking like a network engineer. Cloud Router learns routes from your on-prem via BGP, and by default, it accepts everything your on-prem router advertises. If your on-prem router sends 50 routes, Cloud Router learns all 50 and creates corresponding dynamic routes in your VPC.
That sounds like it could get messy fast.
It absolutely can. Here's where BGP route filtering comes in, but I need to be precise here. Cloud Router itself doesn't have inbound route filtering in the traditional sense like you'd configure on a Cisco or Juniper router. Instead, you control this on the on-premises side by configuring your router to only advertise specific prefixes to GCP.
So the filtering happens at the source, not at Cloud Router?
Correct. On your on-prem router, you'd create a prefix list or route map that limits which networks get advertised to the BGP peer, which is your Cloud Router. For example, if your on-prem has 192.168.0.0 out of 16 for corporate and 172.16.0.0 out of 16 for a legacy system that shouldn't talk to cloud, you configure your on-prem router to only advertise 192.168.0.0 out of 16.
What's a common mistake people make with this setup?
The biggest one I see is forgetting about the default route. Some organizations advertise 0.0.0.0 out of 0 from on-prem to GCP, thinking it'll help with internet egress through their data center. But this can cause all your GCP internet-bound traffic to hairpin through your VPN tunnel, crushing your bandwidth and adding latency.
Oh no, I've actually seen that happen. Traffic was crawling and we couldn't figure out why.
The fix is being explicit about your advertisements. Never advertise 0.0.0.0 out of 0 unless you absolutely need it. And if you do, understand the traffic implications. Also, use Cloud Router's BGP session monitoring to verify what routes are actually being exchanged. In the console, you can see learned routes and advertised routes for each BGP session.
Let me make sure I've got this. Custom route advertisement controls what GCP tells on-prem about, and I configure that directly in Cloud Router. But filtering what on-prem advertises to GCP happens on my on-prem router, not in Cloud Router.
Perfect summary. And one pro tip: always document your route advertisements in both directions. Create a simple table showing source, destination, and advertised prefixes. When something breaks at 2 a.m., you'll thank yourself.
This is super helpful. So my 3 takeaways are: switch from default to custom route advertisement to control what GCP shares, configure prefix filters on your on-prem router to control inbound routes, and never advertise a default route unless you really mean it.
Nailed it. And if you want to test this safely, set up a lab environment with Cloud VPN and a simulated on-prem router using something like pfSense. Practice custom advertisements before touching production.
That's a great idea. I'm definitely going to try that this weekend.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone building hybrid cloud architectures. This stuff trips up so many people.
Thanks for watching the Network Ninja CloudCast. See you in the next one.